Nature of aqueous solutions of some salts. This is today's lesson. In this lesson, we are going to learn nature of aqueous solutions of some salts, whether acidic or basic, and the reason behind this. So, let's begin. First salt is copper sulfate. This is acidic or basic. Solution of copper sulfate is acidic or basic. This is what we are going to learn today. Normally, water is neutral. This is water, which is neutral because here concentration of hydrogen ion is equal to concentration of hydroxide ion. That is why water is normally neutral, but when salt of copper sulfate is added to water, then the nature of the solution is acidic or basic. Here, copper sulfate is a salt of weak base, cupric hydroxide, and this is salt of strong acid, sulfuric acid. So normally we can say that solution of copper sulfate is acidic in nature because this salt consists of weak base, cupric hydroxide, and strong acid, sulfuric acid. So solution of copper sulfate is acidic in nature. Another way to explain this: copper sulfate, when dissolved in water, then it ionizes to copper 2+ ion and sulfate ion. Here copper 2+ is strong weak acid, strong conjugate acid of weak base, cupric hydroxide. Copper 2+ ion is strong conjugate acid of weak base, but sulfate ion is weak conjugate base of strong acid, sulfuric acid. As it is weak base, it is stable in solution, but this is strong conjugate acid. It undergoes hydrolysis in water, and as a result this is formed cupric hydroxide and proton. That is, here water undergoes heterolytic fission. Here it becomes negative in charge, hydrogen becomes positive in charge. Hydroxide ion combines with copper 2+ ion to form cupric hydroxide, and hydrogen ion gets removed. That is, in the solution concentration of hydrogen ion increases due to the addition of copper sulfate salt. That is, ultimately acidic nature is existed by the addition of copper sulfate. Solution becomes acidic in nature. Due to the increase of the concentration of hydrogen ion. acidic nature of copper sulfate solution. Now, ferric chloride. When ferric chloride is dissolved in water, then it ionizes to ferric ion and chloride ion. Ferric ion is strong conjugate acid of weak base ferric hydroxide, but chloride ion is weak conjugate base of strong acid hydrochloric acid. So ferric ion undergoes hydrolysis in water to form ferric hydroxide and proton. That is, here hydrolysis occurs. Oxygen hydrogen bond undergoes heterolytic fission. Hydroxide ion positively charged hydrogen. Hydroxide ion combines with ferric ion to form ferric hydroxide, and hydrogen ion gets removed. That is, in the solution, concentration of hydrogen ion increases. That is, here suppose water, ferric chloride salt is added in the water, then concentration of hydrogen ion increases through hydrolysis of ferric ion. That is, solution gets acidic in nature. Simply we can say that ferric chloride is the salt of weak base ferric hydroxide and strong acid hydrochloric acid. As it is made up of strong acid and weak base, so the solution is acidic in nature. Solution of ferric chloride is acidic in nature. Now, sodium bicarbonate. Let us see whether this is acidic or basic. We know that water is neutral when sodium bicarbonate salt is added to water, then this is acidic or basic. This is actually not acidic. Solution of sodium bicarbonate is basic in nature. Let us see the reason. Sodium bicarbonate is composed of strong base sodium hydroxide and weak acid carbonic acid. As it is made up of strong base sodium hydroxide, the solution is basic in nature. Again, when sodium bicarbonate is dissolved in water, it ionizes to sodium ion and bicarbonate ion. Sodium ion is weak conjugate acid of strong base sodium hydroxide. As it is weak conjugate acid, it remains hydrated only, like this. But bicarbonate is strong conjugate base of weak acid carbonic acid. As it is strong conjugate base, it undergoes hydrolysis. This bond breaks heterolytically. It becomes negative in charge. It becomes positive in charge. This positively charged hydrogen combines with bicarbonate ion to form carbonic acid, and hydroxide ion gets removed. In this way, in the solution, concentration of hydroxide ion increases. That results in the basicity of the solution. That is, solution of sodium bicarbonate is basic in nature. No more today. Thank you very much.